Today's LeetCode problem. The question is step-by-step directions from a binary tree node to another. This is a LeetCode medium question. Let's see what the question is asking. So we have given the root of a binary tree n. Each node is uniquely assigned a value from 1 to n, and you are also given an integer start value representing the value of the start s and the different integer destination value representing the value of the destination node t. Find the shortest path starting from the node S and ending at node T. Generate step-by-step direction of such path as a string consisting of only the uppercase letter L, R, U, and each letter indicates a specific direction. Right? L means to go from a left to its left child node, and R means to go from right node from node to its right child. Right? And U means to go from node to its parent value. We need to return the step-by-step direction of the shortest path from node S to node T. So basically the question is asking to find the directions shortest path within the start node and the destination node, right? So if you see the first example, here 3 is present at here and 6 is present here. So if we want to go from start to destination value, the first is we need to go its parent, so u, then again to its parent u, then go to its left l r, sorry, right r, and then go to its left, which is l. So uurl is a uh, uurl is a the string which we get, right? And this is the shortest path. Okay. So now if you think of any other then you see that from 3 to 6 the common is which road, this 5, right? And finding finding the finding the shortest path, we need to move in we need to find the common route between the start common route, which common shortest route, right? Common nearest route between the start value, between the start route and the destination value, right? So uh, which means it means that for finding the shortest we need to because if you see for this 3, the common for the 3 and 6, which is the common root, it is not 1, it is not 2, it is 5, right? So from 5 this both nodes can be reached, right? Both routes can be reached. So this can be a shortest route. But suppose there is some examples like okay. Suppose there is some example like this 5 and this one, this one, and also like, okay, let's make this as a 3, right? And also let's take it as here, from start from here, right? This start from here, and this becomes like 2, then we start from here from like 6, right? So basically, if we want to find the common root between 3 and 6, it will be 5 also, but nearest one is 1, right? From 1 we can reach to 3 and 6 both. So we need to find the shortest path. So we don't take 5. We don't take 5 as a common route, nearest route. We will take 1 because we need to find the shortest. Now if you see from 3 to 6, if we want to reach, we can reach from 1, right? So from 3 to 6, we will move to u, its parent, then right, then left, u are left, right? So basically we need to we need to the first thing what we need to find, we need to find its lowest common ancestor, lowest common ancestor. Okay. So this is a very famous problem, LCA. If you haven't solved it, this is a basic starting problem of tree. If you haven't solved it, please solve it. I will also discuss this thing here, but please first solve it when I discuss it. If you don't know, right, please solve it first, right? So how we find LCA, right? So basically for finding the lowest common ancestor, what we need to do, we will move from the root node, which is 5, of course, until each and every node, right? And the lowest common ancestor between which values, one is start value and the destination value, this is the two values we have, right? So when I start moving its left and right value, what we will do, we will check that whether at any node I am getting at a start value or not, right? Or destination value, anything. If I'm getting that, I will return that node, right? I will return that node. If I'm not getting, I will return null, right? So basically what I means to say, Suppose I have taken this example, right? So I have started from 5, right? I have started from 5. So when I go to left value, when I move to left value, this left value is start. So take start value as a 3 and take destination value as 6, right? I'm just discussing lowest common ancestor. After this, finding the paths is very easy, right? Because we know that from this low LCA value I can reach to both of the nodes, right? And we can simply discuss that, right? So we will find the LCA between this 3 and 6. So what we do, we will start from the root value, we will move to its left and the right, because I need to find this 3 and 6, then only I can find that which is the uh, common root from where I have reached to this, right? So I have started from 5. I will move to its left and the right. Right? Let's suppose there is also right value. Let's take it as a 7. Okay. So I will move to its 7, right? So is this 7 has a value start or destination? No, it will return null, of course, right? So if it is return null, so we will this has the right value which is null, right? We will move to its left value. This one is not common. We will move to its left and the right value. This one left and right value. So this left value is 3, right? It means this is start value is 3 and this is also 3. It means we got the node start value. Either we got the start value. So we will return this 3. So the left part gives me something, right? The left of 1 gives me something, right? Which is 3, right? It means if this left will give me something, this 3 is for sure we are getting, right? When we move to 2, when we move to 2, this 2, this 2 is not equals to either 3 or 6, right? It is not equal. So if it is not equal, why I'm checking for, because there is no duplication value, right? So I am checking for 2, it is not equals to either start or destination, so we will move to its left and right if it is available, right? If it is as available, I will move to its left hand value. If it is not, then we will return simply null, but it has a available left value. So we will move to its left and the right value. The right value gives me null, right? The right value gives me null, but the left value gives me 6, which is the value of destination. So it means I can return the 6, right? I have gotten something, right? So if I return 6, it means I have some values for 2, right? Which is not null. I Right value is null, but left value is not null, right? So 6 can be written here from here. So I have written 6 here, right? So if you see now, the one has this one root, the left node is also we have, and the right node we also have, right? It means any of the node is not null, right? It means this root node will definitely have a common values between 3 and 6, because its left value containing starting one value, and the sixth node containing the right mode, right? It means, so what does it mean for solving LCA, for getting LCA value, LCA node? What we need to do, we just move in left and right child of each node, and if we get the start or the destination node at any point, I will return that node to my parent, right? And if at any parent it's left and right, no if left and right value node is not not is not null, is not null, then it means that node must be an LCA node, right? Because if you see, if 2 is if 2 has, if suppose this 2 is not an LCA value, so its left right part is null, but its left value has something. So but this one has both of the nodes as some values. It means this will definitely be a one value. You can also take some other examples, but this thing is necessary to find the nearest LCA, right? LCA means lowest common ancestor, right? This is the final for final finding the LCA part, right? So basically, when we got to know this one, it means LCA is one now, right? LCA is one. Now for finding from LCA1, I know that its children has containing this start and the destination node. I just need to find the this path UURL, right? This path. So what we need to do, we will start to find path, right? We will start for finding path from. So start now the starting word we LCA, and we need to find to start, right? Also we need to find path for LCA to destination, right? Now one thing to note that we would start to destination, right? The final answer should be the start from destination, but we are finding from LCA to start, right? We are finding to LCA to start. So basically if you see here one thing, that suppose this 5 to 3, when you move to it is left and left, but what should be there? It should be the parent, which is you. So from 3 to 5 it should be you and you, but what I get left and left. It means that from LCA to start there will be only only character u. There should be only character u. There must be only character u in string, because we need to go move from start to LCA, and it always be a parent. When we move from start to LCA, it always a parent. But for finding that which from how many times this parent will go, you will need to move. We need to move from LCA to start, right? So we will find the start and the destination path from LCA. But for start value, this should be u, not l or r, right? And this for this, for destination value, that will be the same, either l or r, right? So it means I need to somehow know that if I'm moving from start to LCA, I will only include u in my answer when whichever path I am moving. And for finding LCA to destination, I will use l or r, which according to the path I'm moving, and I will just combine both of them. I will combine both of the paths, both of the string paths, which I will got, which I will, right? And that will be my answer, right? That will be my answer. So this is enough to solve your problem. First thing is to main is to find LCA, right? If you don't know LCA, this is just that you need to move each and every child, and whenever you get a value start or destination, you will return that node, right? And if you get left and right node until this parent as a not a null value, then you will just return that node as a LCA. Otherwise you will return the value which is not null, either left or the right. Just we have written for 2, this left value is not null, so we have written 6, not this null, right? So this is how we will solve this problem. Let's just implement it, you will understand it better. So first thing is to find is LCA, right? So we will find the LCA, right? So let's find the LCA, right? So the tree node, first need to find LCA. So this is lowest, let's take is the lowest, right? Find LCA, right? First thing is to root the start value. This is the start value. Let's make it as a start, and this is destination, right? So this is the start value, and this is the destination value, right? Suppose I got start and destination, right? Suppose I got a start destination. So what I need to do? Suppose I got a LCA, right? So what I need to do? I need to find path. For finding path, what we need to do? We need to just to know that we need to find two of the strings for finding the paths, right? So what we do, we will start finding the path for start, right? Which will be a string, and also path for destination, right? Which is also empty string. Now what we do, we need to call some find path, right? Find path, which will be started from LCA from 2 till this start value, and this will be the string which will be stored the path, right? Same goes for the destination, right? But the thing is here that okay, sorry. The first thing is here that I need to know. One thing is to know that for finding LCA to start, we need to know that this there must be U only, right? There must be a U only, right? Then don't be L and R. So I need to know that I have started from, right. So what I will do, I will just take a boolean value here, take a boolean value here, which can you represent as okay, just take it as 0 or something, right? Let's take as a 1, and we will pass here as a 0, right? This. So this 1 represent that we have started from start for a start, and this 0 will represent that I will start from destination, right? After this I have got for path for start here and path for destination here. We will just combine both of them. So path for start plus path for this. So either you can take another string, or you can just write like this: path from start plus path for destination, and just return this will be my answer, right? Now the main thing is to find LCA and this implement this function, right? So we will just implement this function. So first thing is to find that LCA node. So tree node LCA, find LCA, this tree node root and start and destination. Either you pass by reference or you not, there is not much effect because this is O of 1 only, right? So it's according to you only, right? You can pass it by reference or not, right? So this root value. Now what the first thing is that I need to move in its left and right. So first thing is left LC, right? Left part. So we will move in left part, root left, start and right. Same goes for right part, right LC, right? And this will be right. Now if any of this is uh, if left part is, if left LCA and right LCA, right LCA is not null. So it means that this root is definitely this root is definitely a LCA value, right? If it is not null, if we are getting some value, right? Otherwise else if left LCA is null, sorry, if left LCA value is present, it means if it is not correct, it means one of the value is definitely null. So if left LCA value is not null, right? If left LCA value is not null, so what we will do, we will just return left LCA. Otherwise we will return right LCA. This is how we done. So this will be fine. So okay, when will this, what is the base case of this problem? So one base case is that if root get null, root is null, so we will return null, right? Second, if root value root value is equals to either start or either destination, it means I will return root, definitely return root, because I got the value either start and destination. So we will return root in that case, right? So basically, this is how we find the LCA part, right? This is how we will find the LCA part, right? Now, now we have completed the LCA and we will definitely got LCA part. Now we need to need to implement this find path function, right? We got LCA and we will start from LCA to start, right? Now we need to find the path. So this will be a void function because we haven't, we are just storing in this path for start. So this will be a tree node which will be start from LCA. Let's take it as a, yeah, take it as LCA, no problem. This would be a string which will be dynamic, right? And this will be a boolean value which will be tell me that whether it is from a start or whether it start from it is from for destination, right? So one gives me start value, right? Now if this s value, right, this s value, I will push back, I will take if this check value, right, this check value is 1, it means i need to take I need to take u, only u, right? Otherwise I will take the L value first because I'm moving to its right left part, right? Its left part. So find path LCA ka left, LCA to left, and this is S and this is check. Now When I move to this, when I move to this, when I am coming back, when I'm coming back, I need to backtrack this, right? When I'm coming back, I need to backtrack this, right? So first thing is to that, if I got the value, if I got the value, it means I don't need to move back, right? So this is, so what, so this will tell me that whether I am getting the value or not. If I am getting the value, so I will return one. So if I get some values, I will return simply one, right? I will return simply one, right? So for returning one, what we need to do, we need to check the bull that whether I'm getting anything or not, right? So basically what I will do, I will check for the its last value, whether at last value, which is LCA ka value, or LCA ka value is equals to this start value, which is also okay. I have not taken start. This will be start, right? This will be start. So this value, if is equals to start value, it means I got the values. I got the value. If I got the value, I will return one, because how will I confirm that whether we have gotten a value, right? So I need to return something, right? I need to return something. So what I will do, I will just return one. And if this value is one, so I will return one from here, because I don't need to check for further here. But if it is not returning one, so we will not return from here. So we need to move to its right value also. So for moving its right value, I have pushed back uh, u or l, and it is by it is passing by reference, so it will be updated. So I need to also backtrack this. So for backtrack, I will just pop back. So this is just for backtrack, right? This is just for backtrack. This is simple, like to find the paths, right? This is simply like find the paths. Now what do we need to do? I need to do the same thing here, just for right values. This will be now right, and this will be the same as this, right? I will move to its right value, check for, okay, this will be the start, this will be the start, this will be the start, right? Now I will check for the return one, and same thing goes on, that if I don't get for the right, I will pop back this, right? I will pop back. So this will be as dot pop back, right? So what I have done, this check is representing, so this is something like you can write like this also, right? uh, how can you write like this? So basically it can also like as dot, without as dot pushback, you can write like s plus uh, u or something like that, right? In conditional format, right? If this is check, then you can write it, if check is equals to 1, then you can write like this, it will be u, otherwise it will be well, right? You can write like this. This is also true. Either you can write like this, or you can write like previous, right? This is also true. This is taking some extra space, some low spaces, right? So this is working good, right? This is something like good, right? So I will return like that. One thing also, if LCA is uh, null value, so it will return 0, right? So it is just a base case. You can find the base case, right? And after that, if both of the right and the left path doesn't have got the values, so at last we need to return something which will be 0, because we haven't got anything, right, till now. So this is how we will find the path. Now one thing's to know that if from start, for LCA to start, it will return u, otherwise it will get l and r. And after that, it will give me a string for path, path for start and path for destination to this values, and that will be pass, right? Let's just try to run this, and let's see whether we have made any compilation error or not. Yeah, we have made a compilation error. And what is that? Okay, this should be destination, not end. Another thing, no, that's wrong. This start and end obviously comes mind. Okay, this would be closing, and under this is closing also, right? That's wrong. Again. This is destination. This is also destination. Yeah. Okay. Many compilation are there. I think now it will be good. Yeah, we have passed the sample case. Let's submit it. Yeah, we have passed all the test cases. Now, the thing is that the question is very easy. You just need to know that we need to find the lowest common ancestor. If you know that how to find lowest common ancestor, which is obviously a, a basic starting when you try to learn this tree part. So this is basically easy. You just need to go left and right and find if you got the values as a start and destination value are the same. You will return that route. Otherwise, you don't. That's the same thing part LCS. Now you just need to start iterating from LCA to start and destination. The tricky part is that if you move to start from LCA to start, you need to append U instead of L or R, because finally you need to move from start to destination now. So start to route, then route to destination, but you are moving from route to start and route to destination, so you need to put U instead of L and R, and that's how this is question is solved. So yeah, implementation is some bit long, but yeah, this is how. So let's analyze the time complexity, right? The first thing is, for finding LCA, you need to move in all the directions. So that that can take O of n. From LCA to start, it can also take O of n, and from LCA to destination path, it can also take O of n by 2 or F n by 2 in maximum cases. So yeah, that's was O of n. Now, the space complexity is, if you consider because we have taken path for start and path of destination as a string, as an extra string. So that can go from that can go from O of n, and that is extra spaces. And the recursion stack space would be also there because we are moving in recursion, so that will be also there. So obviously it overall is O of n. So yeah, time complexity and the space complexity for this problem is O of n. So this is how we solve this question. Hope you liked it. First, you also if you don't haven't solved LCA problem, you first first solve LCA problem, right? Then move to this. It will be very easy. Thank you so much. Bye bye.